How's everyone doing today? That intro took about half of my time, so I gotta really roll through these slides. So I'm here today. I want to talk a little bit about development, alphabet soup, which is kind of a bunch of random stuff that I don't want to be a whiner. I don't want to be a complainer, but frankly, I'm tired of seeing a lot of these common mistakes in mobile applications that I'm reviewing. So I kind of wanted to go over a few of those things I see, not only from a development perspective, but also from a mobile device management perspective. We're making it way too hard on ourselves, and I wanted to go over some real simple solutions to some of these issues. This is me. He already went over a lot of that. So let's talk about mobile AppSec. So obviously there's mobile top 10 through OWASP. It's been around for a while. There's going to be a refresh next year, which is pretty awesome. But I wanted to talk about kind of the top 5 areas that I'm seeing and talk about some real simple things that you can do as a developer to maybe mitigate some of the issues that I continually see in applications I review. Obviously, sensitive data protection, I think, for most people is the biggest problem that we face with mobile, mostly because these devices are easily lost or stolen. I think all of us understand that. I can easily leave it in a cab, in my rental car, in Starbucks, maybe if I'm out at the bar drinking too much like Jack last night, but that happens, right? So OWASP Top 10 breaks it down into both transport and storage of sensitive data. I like to kind of lump it all into one area because at the end of the day, it's protecting sensitive data. Server-side controls. For some reason, we've kind of forgotten about server-side controls when, in fact, we should remember them, right? So we're taking these steel buildings that we've created for years, our web applications, and opening them up to these mobile apps through web services or however else we're giving users access. So it's like we're slapping these wooden doors now on our steel building. And why are we doing that? So I want to talk about a few of those that I see quite a bit. Authentication, authorization, obviously those issues are continuing because a lot of the built-in OS mechanisms aren't really well understood when we're doing client-side development. And this whole client-server notion is something we did 15 years ago, and it's kind of back, right? That's what a mobile app is for the most part. It's a client-server app. Session management's an interesting one, and we'll talk about that as well, because we're used to using our Java built-in sessions, our .NET built-in sessions. But what do we do when we move to Objective-C and we're using a Java backend? How do we manage the session between the two? And broken crypto, and really it's not broken, it's just misused or implemented incorrectly. And we're seeing a lot of that when it comes to mobile apps. So let's dig right in. Protecting sensitive data. Obviously, this is the focus. Most of the applications that I'm assessing for organizations, this is really what they want an idea of. Is there data there? If there is, where's it going? How long is it there? Is it being destroyed properly? Is it encrypted? Yada, yada, yada. So the reason this is we have these devices. There's many, many, many protocols. How do we secure them? I've seen a few apps that change the way they're talking based on what protocol is being used. There was one that it specifically checked if there was Wi-Fi access and they'd use SSL, but if it was cellular access, we'll turn off SSL and not use it because that's safe, right? Let's not do that anymore. So how do we protect data? Obviously, SSL. There's been ways that SSL is broken, but it's better than not using it at all. I would say the biggest issue that I see from a mobile perspective is mobile applications I'm assessing do not prompt the user when there's a bad certificate. So if I connect to my BERT proxy and all of a sudden I'm proxying traffic without saying yes, accept cert, or installing my certificate on the mobile device, why is that a bad thing? Researchers found tons and tons of these types of flaws in Android apps recently. They looked at the top 13,500 applications, the free ones in the Android App Store. And most of them were doing SSL either wrong, they weren't requiring SSL, or they were just allowing self-signed certificates. We think about that and we're like, well, that's not a big deal, but remember, I'm going around, I'm connecting automatically to Starbucks, I'm connecting automatically to my library Wi-Fi. If someone's running a rogue AP with the same name and a proxy, I'm screwed. All my data is going over it, and my mobile app doesn't care. And there's some easy ways to prevent this, but for some reason we're not doing it. So in Android, you can set the hostname verifier. Now, that being said, this setting, browser compatible hostname verifier, is default. right? It's default now in more recent versions of Android, but me being the security guy I am, I still recommend hard coding this in your app, because what happens when Google changes it? They've been known to do that. Apple does it too, right? Hard code it in your app. Make sure you're doing the appropriate validation when you're making connections through SSL. Make sure that it's validating the cert not only for the host name, but everything else that's involved in that validation. It's pretty easy. You know, don't use your own trust stores or trust managers unless you really have to and you're doing something like cert pinning. Use some of the built-in functionality. iOS, similar sort of thing. We run into these issues a lot. I can't tell you how many times I see this. Set always any HTTPS certificate for host. Anyone know why that's set most of the time? No? Development, right? It's a whole lot easier for me to set this when I'm using the simulator, because frankly, adding my self-signed cert to the simulator is a pain if I have to do it all the time, right? For a while there, it was really hard. You had to grab it off of a device and put it into your simulator to be able to use it. Now there's some scripting that'll add it for you. But I set this so I can test, so I can do some development. What happens when that's forgotten about and it's deployed to production? Now I'm accepting any self-signed cert in production. Same problem I was talking about before. This one I'm seeing a lot more too. Continue without credential for authentication challenge. This is used primarily with web views and such. So if there's prefetching and things going on with web views, a lot of times this will bypass those certificate warnings as well. So don't use these. I know even in development it makes it easy, but add the cert to your trust store in development in the simulator instead. Cert pinning. I'm seeing more and more of this. I think it's a good idea. You know, there's a debate going back and forth whether or not it's a good idea, but I like it. There's some good code on OWASP for both iOS and Android. I'd check it out if you want to do some cert pinning. Obviously, what that's doing is it's validating the server and client know they're talking to one another. And you know, through multiple different APIs and so on iOS and Android. Now this is where you'll have to create your own trust manager on Android because they don't have anything really built in to do this cert pinning yet. But again, I recommend it. It makes it more difficult if you change the server cert, and you may have to push out a new app to all your users. But for security reasons, it may be appropriate depending on how security conscious you are. So in iOS, this one still drives me nuts. When users hit the home button or switch applications, what happens? Take a snapshot. It hasn't changed in iOS 7. Actually, it's probably worse in my mind because of the way they're doing some backgrounding. You know, when you double click the home button, you can see all the apps that are open. Those are snapshots of your last viewed screen, right? What if that screen has something like your credit card number, your social security number, anything else that may be sensitive to you? Now it's in a snapshot. If I had access or root access to your file system, I have that. It's a simple solution, though. There's a couple delegate methods you could use to make sure and change that screen to something without sensitive data before it takes a snapshot, right? And a lot of this is built-in OS functionality that you're not going to be able to change, right? But you have to understand that it's doing that. This one drives me completely up a wall. The number of passwords that are being stored in preferences files and plist files is staggering. It's almost like we don't think people will have access to the file system. Let's not do this anymore. Don't use shared preferences for passwords. With iOS, plist, obviously, every application has a default plist file. NSUser defaults uses that. Now, I've seen passwords stored in the default plist file, I'll bet probably 1 in 3 apps that I look at. And I don't know what it is, but developers might think that NSUser defaults is memory based, but it's actually storing the data in a file that's on the file system. So if I have root access again, I can get at that information. Other one, autocorrection. How many get sick of texting or emailing and it changes words for you? I do. You can turn it off as a user, but then you're like, well, why aren't you autocorrecting me anymore? It's like this fight between yes and no, right? Well, both iOS and Android have storage mechanisms for this. And they do this because they want to remember you. So if you continually type the same word or phrase, it's storing it either in a flat file on iOS or in a SQLite database on Android. Now, as a developer, you have to understand this. It's not just like autocomplete and so on in a browser. This is stored forever. In iOS, for instance, it's synced. my dynamic text.dat file is huge, right? I mean, I've had an iOS device for years and years and years, and every time I sync it, it just syncs it back to my device. You gotta think about that. You know, if you're doing sensitive data fields and don't turn autocorrection type to no, it may possibly save that data to those files, again, persisted on the file system and not controllable by your application. So Objective-C is pretty simple. Set this attribute type on your text fields, and you'll turn off that autocorrection for that specific field. Obviously, browser, still an issue on mobile devices. We have mobile web browsers, and autocorrect off will do the same thing. Now, Android. Android's its own beast. There's ways to turn this off through either your layout, XML, or in your code. You can set specific attributes on those text fields, but it doesn't always work. Anyone know why? Anyone? No? Well, in Android, you can have different keyboards. That keyboard may not listen to these attributes. Now, that being said, I still recommend setting them, but just understand as a business and organization that there may be some devices, you know, maybe Swipe doesn't listen to text flag, no suggestions, and so on. So, again, it doesn't always work. Browser HTML, same sort of issue, turn autocorrect off. Now remember, these are the most common things I'm seeing in applications that I review. You know, I find these things right away, and then it's like, okay, now I can dig into the real stuff. But I think it's one of those things we completely have forgotten about in mobile, and it's time to step up to the plate again. Browser caching. So mobile browser caching is no different than browser caching on your local laptop, desktop, whatever else. Make sure to set the responses appropriately for caching sensitive data or not. Same thing you're going to see if you do a web review and you aren't setting cache headers. These are still applicable in the mobile world, especially with things like your mobile Safari that's now getting synced. I had one guy who did a review of his boss's iPad, right? He said, here's my iPad, do a review, tell me what's on it. And so he synced it to iCloud, grabbed the iCloud sync and applied it to his iPad, and he had everything from his boss's Safari. You know, he was already logged into Gmail and all this other stuff. Right? So make sure to set these cache control headers appropriately because of issues like that. But if you have to store sensitive data or store data at all that you don't necessarily want to be around forever or synced, right? There's specific locations on iOS to store that data, right? So every application has their own root, library, caches. Specifically will not be synced to iTunes or iCloud. Same thing with the /temp directory. So if I connect, say, my iPhone to my device, I, out of the box, can't get access to that. But if I either jailbreak the device or use a forensics tool, more than likely I will have access to that plist file without having to know the passcode. But
what's an example tool?
Lantern I use. But technically that's only available for law enforcement. So anyway, Android, we're good, right?
Yes.
Perfect. Android doesn't necessarily have specific locations. There's lots of syncing tools for Android. You know, Google Sync and anything else that you third party could possibly download to sync your Android devices. Don't store anything on the SD card that may be sensitive, as the SD card's world readable, world writable to any application. So you know, this is cool, right? Because now I can store to an SD card that has tons and tons of gigs available. Just don't do it if it's sensitive in nature at all, and store it in the file system sandbox for the most part. So what's this about a keychain? Obviously, we hear a lot about keychain. Macs have keychains. Now there's this weird random sync between iOS devices and Macs with Mavericks and iOS 703. I haven't looked into that too much, but so your iOS device has a keychain. It's used for storing keys, usernames, email addresses, Wi-Fi information, passwords, etc. But I don't recommend it for anything that's highly sensitive. It is something that an attacker could get access to, either through an iTunes backup or by getting access to your device itself. Specifically email addresses, so like Gmail, for instance. Gmail does store your Gmail account name and your password in the keychain. So if I'm able to dump that keychain, I can get that information. Not only that, I'm still looking into this, but if you delete your email account from your device, that information still remains in your keychain. Not sure why. So I got to look into that further. But there are some settings or attributes you can set on these when you're setting them in the keychain. This is the default with iOS, I think it's 6 plus. KSEC adder accessible when unlocked. What that means is that attribute or value or whatever is only accessible once the user unlocks the device with whatever passcode it is, right? And then obviously a little bit stronger, this device only, it's only that device. So even if I sync it to iCloud and I pull that sync to another device, I have to re-add that information to make it accessible only to that device. But there's a caveat to this. It only works if the device has a passcode set, which you can't necessarily require from your application, right? So you can't rely on these attributes to work if the user just has a wide open device. So this is kind of what it would look like. So this is just an SSID that I did a dump of a keychain. And obviously you have the account or the SSID and a really bad password in the clear. So that information is available even though it's supposed to be secured. So make sure what you're storing in there isn't something that, if lost, is going to be detrimental. So always use SSL. I think that's a no-brainer. Don't switch back and forth, right? We've used SSL long enough. It's not really slowing your system down that much. Turn it on, use it. Don't store sensitive data locally if possible. If you need to, there's mechanisms to do that, and we'll talk about that as I move on. And then obviously caching is something to think about, both client, server side, and if you're using any HTML5 or anything like that as well. So server-side controls, why is that still important? This is a client device. I can't tell you the number of organizations that will come to me and say, hey, can you assess my mobile app? And I say, okay, fine. Is it what kind of mobile app is it? Oh, it's using web services and that, but I just want the mobile app assessed. Well, what's the point of that? It's not going to tell me anything, right? If I'm just looking at the mobile app, I might find a couple things in your code. Maybe you're storing some sensitive data, but I should assess the whole thing, right? You should have controls on the server side, authentication, authorization, SQLi protection, XSS, which is still a problem in mobile apps, and actually is more of a problem in mobile apps because you have local file system access with XSS, like you wouldn't in a browser. So if I try to reference a file through XSS with a browser, I don't have access due to SOP, right? But in mobile apps, if I'm using WebKit, WebViews, anything like that, and the XSS says, hey, I want this file, as long as the app has access to the file, you have access to the file. It's unfortunate, but that's the way it works. So don't forget about your typical server-side controls, right? We've worked for years and years and years protecting our web apps and our other client-server apps. And now we're slapping these mobile apps in front of it and think we just need to assess them. If they're secure, we're secure. No, not necessarily, right? Because control should, for the most part, still remain on the server side, because that's where we can control them, right? And this is number 2 from what we're seeing at AppSec when we're assessing applications. Poorly implemented server-side controls, forgotten about server-side controls, and so on. So how do we do it? All right, how do attackers do it? Same way we did it and still do it today with web apps. Security proxies, guess what? Yes, you can use them with mobile apps. It's just web traffic for the most part, right? Most mobile applications are using web services, are sending JSON requests, are getting XML responses, right? All over HTTP or HTTPS. So these tools will still work, and we use them frequently. Jailbreak and rooting tools, there's tons and tons of them. Evasion will probably be out very soon for iOS 7. They talk about it every day on Twitter. We'll see. Android, it's basically one per device anymore, it seems like. But there's plenty of tools to get root access to your devices. So, when you're developing, you got to understand that you're probably developing for a device that's been compromised, if you want to call it compromised. So you got to understand that when you're developing. And then anything else, there's some apps, such as Good for Enterprise. It uses UDP traffic. Don't know why, but they do. So we can use other tools like Mallory or Wireshark to analyze that network traffic. All right, any questions on sensitive data protection or not? And authentication authorization. So obviously, there's a couple different things. There's the OS side, which the developers can't really control, and then there's the application side. right? So Apple's added this whole fingerprint sensing thing and all that. If you ask me, it's not for security, but it's convenience. But again, don't do this anymore, okay? That's easy to say. Don't store passwords locally. There's no reason for it. We're doing Remember Me in mobile because we don't want to put pressure on our users to have to type in a password. Well, they're typing in passwords on the web. Why is this small computer any different? It might not be as easy. They might have, fat finger it more. But stop trying to do Remember Me. Sure, have longer sessions if that's what you want, like your Facebooks and things like that have sessions that last for pretty much ever. But don't store their credentials. Or, in the case of I have a banking app. It not only doesn't store my credentials, but I have two things. One, I register the device to me, so I can only log in their mobile app from me, from my device. And my mobile username and password is different than my web username and password. So if someone compromises that, they can't just go to their mobile app and use that because they haven't registered that mobile device to me. And they can't use it on the web because it's just for mobile. Something to think about, right? So keychain, don't store passwords here either. Again, I just showed you that all that's in the clear for the most part, if I get access to your keychain. What about for those apps that really want to store sensitive data? There's a couple mechanisms. SQL Cipher is a pretty good mechanism for storing sensitive data. You still need some sort of key. How do you get that key? Maybe it's something you require the user to type in as a passcode. But again, you're still requiring them to type something in. Or you employ some sort of DEC model, like Good for Enterprise does, like a lot of your password managers do, 1Password and so on, where they require a master passkey for you to type it in, which then unlocks your disk encryption key, and then together they decrypt the data that's stored locally, right? But here, again, you're still requiring the user to type something in. So for server-side auth, use what you already have. Use your SiteMinders, your SSO implementations, custom authenticators, two-factor auth, whatever you're using today for any sort of authentication, use it in the mobile world. It's just another interface, right? It's another channel that you're opening up to your already established infrastructure. So continue to use that infrastructure. Don't reinvent the wheel. So what about authorization, right? Kind of goes hand in hand with authentication, who you are and what you can do. There's two of them, right? OS-based and application-based. OS-based is different based on iOS and Android. And I focus on iOS and Android because, frankly, if you tell yourself there's going to be anything else in the next 5 years, you're crazy, right? Windows hasn't taken off, at least in the US. I'm not sure about the Firefox stuff yet. But anything beyond iOS and Android, I'm not sure yet. So iOS Sandbox or Seatbelt, whatever you want to call it, right? So it's based on a trusted BSD Mac framework. There's user space library functions for each of those sandboxes because every app actually runs under the same user. Every app runs under the mobile user. So they have to segregate them somehow, which the sandboxing limits your app access to its own file system. So every app has their own file system with a very well-defined set of subdirectories. So when you install an app, every app has this list of subdirectories. And that's all that it can technically access other than maybe some shared resources and so on, and we'll talk about that here. So what about the permissions model? So I've installed my app. It has access to its file system, but I want to get access to the camera, or I want access to the microphone, maybe contacts, photos, something else. That app and the OS specifically asks the user, hey, can I have access to this? And the user can click OK or don't allow. The app will still function, or at least it should, if you click don't allow. But once you've clicked OK, it's always on until you specifically turn it off. So the first one they implemented this with is location services. It seems like every time they deploy a new version of iOS, they add another one. I think the last one was the microphone that was added as something that now apps have to request access to use. But again, remember, you can turn it off. But once you turn it on, you have to turn it off for it to go off. They don't ask every single time. Android, completely different model, right, when it comes to the apps and how they run and the authentication, authorization. Every app has its own user ID in this case. That's how they do file system separation. for each of the applications. So that app only has access to its file system, but it's through their user ID, not necessarily through that sandboxing technique that Apple uses. Shared resources are handled by permissions model, which is obviously different than iOS, and I'll talk about that. But what about rooted devices? Obviously, that completely destroys the sandbox. Same thing in iOS, right? And there's quite a few holes at that point. So if I have a rooted device with Android, the Google Play Store has tons and tons of apps in them that need root to work. So me as a security person, I download things like ProxyDroid. It allows me to proxy traffic from a device. It has to have root access to be able to do that proxy. So I can get those from the App Store, right? So think about that when you're not only developing, but trying to manage these mobile devices as your organization. So the permissions model, completely different than iOS. When you install an app, it requests the permissions that that app needs, all of them. It was funny, someone deployed an app called All Permissions. All it did was request every single permission in Android, and it was downloaded and installed like 10,000 times. Why? Right? Users are not smart enough to understand what these mean, and even the crappy descriptions underneath of them don't really tell you what they mean. But that's the model, right? It's a yes or no. If you click no, the app won't install, because if it did, it wouldn't work, right? It needs all of those to actually function, I guess. So be cognizant of what you're not only developing and asking users to approve, but when you're installing an application on your personal device, business device, understand what some of these mean. We actually have one of our engineers created an app that will look at all the permissions and all the apps that you have installed on your device and kind of give them a rating. I don't have it on here yet, but something to look for in the Google Play Store if you're interested. It doesn't do anything else, it just grabs that information and kind of gives you a rating of each app and tells you some of the more risky permissions that your apps are asking for. So obviously there's different levels of access control when you're talking about applications. I would say most all these on the server side. You can't manage access control locally on the client because you can't trust it, right? There's presentation layer, that one's a usability option, so it's different screens you might show, different buttons you might show on your mobile app. But in the back end, you need to validate that Joe has access to delete Sam's account, right? And that's done through multiple layers, whether it's environment-based, URL-based access control. Because remember, we're still talking over the web for the most part. It's no different than our web apps. You've got controller, you've got business logic, you've got data layer access control, so I can only access my data and you can only access your data. So all that should remain, but direct object referencing is still a huge problem in mobile apps, and I'm not sure why. So just remember, put these on the server side, continue to do what we're doing in the web world, in the mobile world. Session management. This is a little bit more difficult. Like I've mentioned before, we're used to our Java sessions, our .NET sessions. Our browsers manage it for us through cookies. We do all the session management on the server side, whether it's timeouts, logouts, logouts, and things like that. And most of that we can continue to do. Rely on the server-side session management. Rely on your Java backends and your .NET backends that you're using and just employing this front-end iOS or Android app. Do all your session management, your timeouts and so on the server side, but you can mirror them. Now I said mirror them on the client side. Don't rely on the client side to do it all for you, but mirror them. Mirror the timeouts. Sometimes we want shorter session timeouts with mobile apps because users typically aren't spending tons and tons of time doing a bank transfer from their mobile app, something like that. So in iOS, so what do we do, right? So in the web world, these session IDs are transferred through cookies, right? So if I request access, I authenticate, now I have the session ID, and it sends it to me over a cookie to my mobile app. I got to store that somewhere because I'm not in a browser now. I'm in a mobile client. So where should I store it? iOS, I would say the first option would be in the keychain. Now, it's not the most secure option, but at least with session IDs, they're going to time out at some point. So even if I did get access to someone else's keychain, which had the session ID in it, hopefully by that point it's been expired, timed out, right? So I can't just go in and use it again. So that would be my first option for iOS. Again, make sure and set this attribute that we mentioned before. This device only is my preference, especially for session IDs. You should never have to use that on another device. Second option, store it in memory. I don't like that as much, but it's a little bit harder to get to the memory on an iOS device if you don't have the access needed to do that. And third option, which I wouldn't recommend at all, would be plist files, which frankly I see most of the time because it's easy. Just store it in NS user defaults, and I can grab it and use it. But store it in the keychain. I mean, it's a real short amount of code, right? It's not hard to save and then retrieve. Android has a keychain API, but it's completely different than the iOS side. The keychain API is really for storing keys and certificates, and not really for storing strings and passwords and values and such. So you could potentially use it to store a key or cert to encrypt the session ID, but that's probably too much work because the session ID isn't necessarily the most sensitive piece. But stored in memory, I feel a little bit more comfortable with storing session IDs in memory now that Android has implemented some of the USB protections. You know, when you turn on debugging and connect it to a new computer, you have to, from the device, tell that computer that it's okay. Whereas before you didn't. So I turned debugging on, plugged in a new computer, and now I can dump memory. And Android actually has built-in tools for that, so and it's very easy to use. But I'm a little bit more comfortable with the newer versions of Android because it's more restrictive from the USB connections. Crypto. So first, don't do crypto on the client side if you don't really have to. Crypto is best done on very powerful server backends. There's more randomness for the most part. But if you really have to do it on the front end, on the client side, there are some ways to do it. Common problems that I'm coming across, failure to encrypt sensitive data, that would be the number one I see, right? I'm saving it locally, I don't encrypt it because no one can get access to it because it's locked down. Well, that's just not the case. I would say the best choice here is just don't send the sensitive data if possible. Unless you need offline access to this data, there's no reason to send it to the client and store it there. Credential problems, right? And we've talked about that. Storage of all this information, which is a problem in the web world as well. Continues to be a problem with mobile. Hard-coding keys, hard-coding certs, passwords, and so on in source code, I'd say is probably one of the biggest issues that I'm finding when it comes to crypto because they're not sure what to do with it, right? I just would recommend not doing it. And then algorithm problems. I've seen a lot of roll your own in mobile, and I'm not sure why we're going back to that. Use the strong algorithms, yeah, sure, NSA and Snowden, whatever else. You still, use AES, use Twofish, something like that, if you really need to. Hashing. I think this changes about every day, but use strong hashing. Use multiple iterations when you're hashing. Your bcrypt, scrypt, PBKDF2 with SHA-1, 256, whatever you want to use to do a strong hash. Again, this is best done on the server side, though. You're going to be able to do many, many, many more iterations, which just slows down guessing, right? I mean, that's what the iterations are for. If someone really wants to create a rainbow table attack and they know the number of iterations, they can do that. It's not for preventing that. It's more for preventing that brute force guessing than anything. And a lot of this information is on the OAuth site. It doesn't change in the mobile world, so just continue to do that. Encryption, obviously, use some strong algorithms. Everything we've preached in the past continues to be preached. Entropy, here's a good one. Int get random number, return 4. It was done by dice roll, right? That works. Actually, we've had some issues with entropy, specifically with Android. Anything prior to Jelly Bean had an issue with the secure random, and Bitcoin kind of took the hit there. So as long as you're developing for Jelly Bean or beyond, go ahead and use secure random. It's using the appropriate seeds and so on, and should be much better. But if you're developing for any versions prior to Jelly Bean, there is a good link here to check out. It's not very easy, but you can make it a little bit more secure. iOS, the sec random copy bytes is the only thing I'd recommend. It does use dev random for the seeding, but don't use these other ones. They're definitely not random enough. So that's mobile AppSec. I got just very few minutes here. So alphabet soup. What about mobility? So when it comes to mobile, it's not just development anymore. It's this whole device, right? Because we're developing not only for our external clients, we're developing for internal, right? So we have to manage all of that somehow. So we've got all these terms, right? BYOD would be the first one that came to mind. You're not going to stop it. You're just going to have to embrace it. Everyone wants to use what they want to use. There's people who love Android, people who love iOS. So establish agreements with your employees, right? That's the only way to really go about establishing your appropriate BYOD. Choose your tool. You've got to choose some tool to manage that, depending on what you want to give employees access to through BYOD. And lockout for any non-compliance, right? They've agreed to something. If they jailbreak or root their phone and you tell them not to, lock them out and don't let them use it, right? They had their choice, their option to use it, and they didn't listen. It's as simple as that, really. I can't tell you the number of clients that I'm working with that have been working on BYOD and MDM for probably 2 years now, and they're still in pilot phases because they're fighting back and forth. You got to establish those agreements. I mean, that's really the biggest thing. MDM is going to be a little bit more restrictive, right, than BYOD. Some of the MDM tools you can use for BYOD, but if you want access to other things like apps, if you want to set passcode requirements, certain level of security assurance is given, root detection. I wouldn't put a whole lot of emphasis on root detection as most of it's bypassable, just because of the fact that MDM solutions are not running as root. How can you detect root if you're not running as root type of thing? Remote wipe, I think, is something, remote wipe poison pill is something that you should definitely implement. And then app restrictions, I think, is probably the most important aspect here that organizations are struggling with and that I'd recommend. And I'll talk about that why in a minute. Mobile network management, another alphabet soup issue. Providing restrictions based on the mobile device itself, maybe the user of the mobile device. Maybe they're connecting to different Wi-Fi access points than maybe their laptop would at work. Geolocation restrictions, I see more of this where maybe your organization has some internal devices that they don't ever want to leave the campus. And if they leave the campus, geolocation will completely shut them down, right? They can't connect to anything. You can't log in and things like that. Something definitely to look at as far as your more sensitive devices, maybe your development devices. A lot of times there's a lot of restrictions on development devices because there's new code, there's new projects and things being deployed to them that they don't want in the wrong hands. And then MAM, mobile application management. Again, this is where I think I would focus most of my time if I'm looking at MDM solutions. Who provides the best solution? I think when they first started developing MDM, it was more of a, let's just block applications on an application basis. So block this PDF renderer, block this Angry Birds app. Well, obviously, in the security community, we know that doesn't work. That's negative filtering, right? There's millions of apps between Google Play and iOS. You'd have to hire how many full-time people just to manage what apps you're restricting. So that doesn't work anymore. You're going to have to do it a little bit differently. You're going to have to rely on the mobile device management vendors to restrict those. 2 minutes. Holy crap. So some App Store issues, right? We have App Store issues. These type of applications get into the App Store that shouldn't. Apps, tethering apps were huge to begin with, so we can't rely on app stores to protect us. We have to understand that. Functional risks. This is one that, obviously there's open as. I can open PDFs in multiple different things. MDM will help restrict that. What about things like color? Color uses the microphone to detect when people are in the same room. Is that a big deal? What about apps that use microphone to listen in on conversations? Same sort of issue, right? How about ShopKick? ShopKick uses the microphone to listen for like a high-pitched sound when you walk into a store, and it prompts you with coupons and deals for that store. Again, something to think about when you're trying to restrict apps that your users are downloading and installing. Obviously, malware. There's over 1 million according to Trend Micro now. Granted, most of them are between about 6 of them, and most of them are disguised as legitimate applications. and just use premium text messaging. I mean, that's really where they're making their money. There's not a whole lot to worry about from a malware standpoint on the mobile side yet because we still have SQLi, and that seems to be where attackers are focusing their time. Root applications, and then obviously inappropriate apps. Yeah, I know, you use Snapchat for pictures of food, right? So leading MDM technologies, there's tons of them. This is not even a small amount of what's available. I'd say these three are the ones that I look at most often: AirWatch, MobileIron, and Good. And that's just my client base. But what I'm seeing is there's different policies. BYOD has a policy, multiple per platform. So maybe I'm running Good on iOS and MobileIron on Android, or vice versa. And I'm not sure why I'm seeing that, but it seems to be a trend. Whether that's good or bad, I'm not sure. But that's what I see. Same with corporate MDMs. Multiple per platform based MDMs instead of saying, oh, MobileIron is good for everything. I'm not seeing that. So protect your data, push controls to the server, manage your sessions, use strong crypto, understand differences in the mobile OSs, and protect with MDM solutions. Look at that. I don't think we had time for questions, even though we had like a 2-minute break. We got 2 minutes, right? Yeah. I'll let you know in 2 weeks. I'm actually assessing it for a client in the next 2 weeks. So, for money, you can find anything. Yeah, Randy.
What kind of device do you use?
I have an iPhone. I don't want to tell you that I don't like Android, but I don't. So.
Is it jailbroken? Your iPhone?
What's that?
Your iPhone jailbroken?
No, God no. No, that's a restriction from AppSec. But I have plenty of devices that are. Anyone else? Went through really fast. All right, great.